Hi everyone, I am Hariharan, Assistant Professor, Department of Science and Humanities, General Engineering Division, RMK College of Engineering and Technology. Today we'll discuss about a topic called multiplexer and demultiplexer. We call this multiplexer as a mux and demultiplexer as a demux. So why we have to study this multiplexer and demultiplexer, and what are the applications of this mux and demux? At the end of the session, you may understand why we are using this mux and demux, right? So generally, a mux multiplexer means many into one. So let me see this GIF I have given here. On the left hand side, you can see a switch with switch called mux, and right hand side you can see a switch called demux. The switch has many inputs, multiple inputs, and it has only one output, so that is called mux. Similarly, on the right hand side, it has only one input and it has many output, then it is called as demux. So let us go to the topic straight away. Multiplexer, as I told, it is called as mux. A multiplexer is one of the important combination circuits and has wide range of applications. The term multiplexer means many to one. Multiplexer transmits a large number of information channels to a smaller number of channels. A digital multiplexer is a combination circuit that selects a binary information from one of the many input channels and transmits to a single output line. See, I will give an example for multiplexer. So we all know that we have radio stations. We have n number of FM stations. Okay, all comes through channels. Okay, see, for example, you may have a channel like Radio City, Suryan FM, Radio 1. It comes with a different frequency, right? 98.3, 93.5, 108, like this. Okay, but in your FM radio, you can select only one at a time and you can listen. So many input channels, but only one output you can receive at a time. You can take this as an application of mux. Okay, that is why we call it as data selectors. This mux is also called as data selectors. The selection of the particular input channel is controlled by select inputs. We call it as, see, apart from input and output, we have another input called selection input. Okay, digital multiplexer has 2 power n input channels and it can be controlled by n number of select lines. Let me explain this through a block diagram. Okay, let us draw a block diagram called mux. Put it as mux, a square. See, very simple. In digital logic circuit, whatever concept you want to explain, I can explain through a mux. I can explain through a block diagram. Okay, so put a block diagram like this and name it as mux. Now on the left hand side, I am going to draw input lines. Okay, we call this as input lines. On the right hand side, I am going to draw a line, a single line called output line, because your mux has only one output, but it has n number of input channels. Okay, this according to this n number of input channels, you may have n number of select lines. Okay, so let me explain this in the next slide with an example. Yes, let me analyze this mux with example now. For example, if the selection line is 2, then we can have 4 input lines. It is because for n selection lines, there will be a 2 power n input lines. So if the selection line is 2, so 2 power 2 is 4 input lines. Okay, so now you can see the block diagram. It has 4 input lines, 2 selection line, 1 output line. So this type of mux is called as 4 cross 1 mux. Right? Next, let us take another example. Now we take 3 lines. Selection line is 3. If the selection line is 3, obviously it has to come as 8 input lines. That is, for n selection lines, we know that 2 power n input lines. So 2 power 3 is 8 input lines. So you can see the block diagram. So it has 8 input lines, 3 selection line, 1 output line. It is called as 8 cross 1 mux. Similarly, we have 16 cross 1 mux. So 16 cross 1 mux has 16 input lines, 4 selection lines, 1 output lines. Yeah, now comes types of multiplexer. So we have different types of multiplexers. So first one is 2 cross 1 mux. This 2 cross 1 mux has 1 selection line. And 4 cross 1 mux, the 4 cross 1 mux has 2 select lines. 8 cross 1 mux has 3 select lines. 16 cross 1 has 4 select lines. I have listed only 4 types of mux, but even you can have 32 cross 1, 64 cross 1 mux lines. Okay. So general block diagram, how to represent a mux in a block diagram. Okay, so this is the way we have to represent mux. Okay, so it has input, output, select lines. So you can see here input side 2 power n input lines, and selection is n selection line, output is fixed, only 1 output lines. Okay. Yeah, let me discuss about application of multiplexer, right? So you know that application, the mux has 3 important components. One is input lines, we call it as multiple source here, selection line called as selector, single destination called your output. Now what I am going to do, I am going to take a 4 cross 1 mux. So 4 cross 1 mux has 4 input lines D0, D1, D2, D3. It has only 1 output lines. Why? Since it has 4 input lines, you may have 2 selection line A, B. Okay. So let us take this 4 cross 1 mux. So then I can connect 4 different inputs to a single output channel. So to explain this, what I am going to have is, I am going to have an electronic device that gives you the sound output. Let us take MP3 player station. The output of this is a sound, to play songs. Okay, so I am connecting this to a selection line, so to an input line called D0. Next one is my laptop or PC, whatever one you can take it. Okay, the audio output of my laptop is connected to D1. Third one is a digital satellite TV. Okay, this audio output I am connecting to D2. Fourth one, cable TV. This audio output is also connected to a D3. So 4 different audio outputs I have, that I have connected to D0, D1, D2, D3. Right? D0, D1, D2, D3. I have connected here. Okay. This 4 audio outputs I am connecting to a single output surrounding system, sound surrounds systems like this. Okay, so the main role of the speaker is to play songs, right? I have 4 different audio inputs, but only 1 output channel. So how this can be selected? With the help of this selection line, I can select this. Okay, with the help of the selection line, I can select this. So you can see here B A selection line. So since it has 2 inputs, we have 4 combination. Say for example, I want to select MP3 station. Then I have to put this A and B into 0 0. Okay, if I put this as 0 0, the D0 will be selected. So the output of the MP3 player will now move towards this speaker. Now the speaker will play the songs which is available in MP3 player. Okay, no, I want sound from digital satellite TV. Then I have to choose this 1 0 combination. If I choose 1 0 combination, okay, the audio output of this digital satellite will now play in the speaker. Similarly, 1 if I put it, a cable TV output, audio output will be in the surround system, right? So this is an application of mux. Another application I can even say for you. See, we have a mobile phone with us. Okay, your mobile phone has speakers. So what is the purpose of the speaker? The purpose of the speaker in your mobile phone is, it will be useful for a ringing. Okay, it will be useful for a call, reading. Okay, when it is put under speaker mode, it can play MP3 players. It can play songs. It can play video songs. Okay, so whatever you are doing in your mobile phone, that audio visual will be play under your speaker, right? So obviously there will be a mux. Okay, so there will be a mux, so according to that it will play, right? So I think now you may understand about mux application, right? Yes. Now I'm moving to real logic circuit. So far what we have discussed, I told what is mux. Okay, then I have given block diagram for mux. Okay, then I have introduced your applications. Yes, now the real part comes here. How to design, how to draw a 2x1 mux. Okay, so that is what we are going to discuss. Let us analyze this with 2x1, a very basic mux. 2x1 mux. So 2x1 mux means it has two input lines, one output line and one selection line. Let me see this. Draw a logic circuit for this. So very simple. It can be drawn with the help of logic gates. It can be drawn with the help of logic gates. So I have taken two AND gates. Okay, I have taken two AND gates like this. Say you can put it as 1, just put it as 2. It's a 2 input AND gate. Okay, so 2 input, 1, this one is 2. Okay, so 2 inputs of gates. Here also I have given it. The output of the gate is connected to a OR gate and forms a single output. And the selection, and I am making this one input, see, one input to D0, another input of the second gate to D1. The second input of both the gates are connected in this way to a selection line called S. Okay, see, now just listen with this truth table. First, maybe I'll show the block diagram also here. Okay, 2x1 mux, you have to draw like this. Okay, now I'm going to explain this with a truth table, right? Let us draw a truth table like this with one selection line S, that is S, and output line. Now what happens if I put 0 here in the selection line? So it says like this. What happens if I put 0 here? What happens if I put 0 here? If this is 0, say for example this is your NOT gate, it becomes 1. Okay, now this 0 is connected to this gate, so one input of this gate will be 0 and this one is connected here. So you know that AND gate, if any one of the input is 0, the output is 0, right? So this is 0, obviously this output will be 0. So here it is 0, irrespective of this input, this will always become 0. So but this gate will not be selected. Now this one connected here, so obviously this is 1, and now the output of this is depend on this D0. So it is D0. This D0 may be a 0, may be a 1. So if I give input as 0, it will come 0. If I give input as 1, it will come as 1. Okay, that's all. This is what I am going to explain to this truth table. So S is 0, so obvious my Y is D0. My Y is D0. I think now you might have understand this, right? Next is, let me put another option here. Okay, let me put another option. Now S becomes 1. Now S becomes 1. Okay, S becomes 1. Then I have to put this as 1. If this is 1, this gate, it will be 1. Here it is 0, so 0. Now the next part is, this is completely ruled out. Okay, because as you know, as I told, AND gate, if any one of the input is 0, the output is 0. Okay, so this won't play. Now this becomes 1. Now what will be the output here? D1. The output is D1. Okay, this D1 may be 0, may be 1. Okay, yes. Can you understand now what is this 2 cross 1 mux? How the data is getting selected? So input D0, D1. Selection line, based on the selection line, the combination of AND gate becomes zeros or ones, so you will get an output like this. Okay, now I'll just show the block diagram. Yes, this is the block diagram we have discussed in the previous slides, right? Okay, so this is about 2 cross 1 mux. I hope you understand 2 cross 1 mux. Okay. Okay, now I'm just introducing another a pin called E, enable. Okay, so I'll explain this enable pin in the next topic. Okay, yeah, now we look 4 cross 1 mux, right? Yes, this is the block diagram of 4 cross 1 mux. It has 4 input lines, 1 output line, 2 selection lines. Also you can see the symbolic representation here. Now how to convert this block diagram into a logic circuit? So for 4 cross 1 mux, what I have to do is, first let me check how many input lines you have. 4 input lines. So draw 4 AND gates. Okay, like this, 4 AND gates with a selection line A, B, a combination like this. You have to draw a logic circuit in this form. Okay, so once if you draw the logic circuit, then draw the truth table. Okay, so now let me explain this truth table in a 4 different cases. First, let us take selection line as A, B as 0, 0. First take it as 0, 0. Now I will put A as 0, B also 0. Now the connection says, okay, this line, this B itself has 2 connections. So here this will be 0, this will be 1. Here also this is 0, this is 1. Now the selection line combination is connected to AND gates, various AND gates. Now according to this, you can see this. You can see these 4 gates, this 3 out of 4 gates, these 3 gates will have a combination of 0. One input will be 0 for the from the selection line. So all these 3 gates, the gate number 2, gate number 3, gate number 4 is hidden. Okay, whereas gate number 1, this is gate number 1, so this will become 1, this also 1. Now your output is D0. Now your output is D0. So the Y becomes D0. This is how a selection works. Can you understand? Okay, so you know that AND gate, it's a 3 input AND gate here. If any one of the input is 0, the output is 0. So the second, the third, fourth combination of AND gate will be 0. So you will not get any output from that. So you will get output from only first gate. Okay, so this is case 1. Now case 2, let me take the case 2. Okay, let me take a case 2. Yes, 0, 1. Now A, I am going to put it as 1, B, I am going to put it as 0. So this part is 0, this part is 1. Okay, but here this part is 1, this part is 0. Now look at the first gate, first gate combination. This is 1, but this is 0, so this won't work because this is 0. Second part, you can see one input is connected here, so 1. Second also connected here, so 1. So this works. What about third? You can see 0 is connected here, so it won't work, so 0. Fourth one, the fourth gate, that also 0 is connected here, so it won't work. Now according to this, D1 works. Okay, so why you have to put D1? Okay, the input from D1 is selected and it will pass to the OR gate. Okay, now next combination, third combination again. The third combination, yes, 1 0. Now B becomes 1, this becomes 0, this becomes 0. So hence this is 1, this is 0, this is 0, this is 1. Okay, now see it, this gate, here it is, this gate has 1 and this one has 0, so this won't work. Here also this one is 0, so this also does not work. Whereas here both the combinations are 1, both the combinations are 1, so this will work, and this also won't work. So my output is D2, my output is D2. And the last case, that also we'll put and see it. Last case, 1 1. So this becomes 1, this becomes 1, so this is 1 0, this is 1 0. So see, you can see here this is 0, so this won't work. Okay, here it is connected to this also 0, here 0, it won't work. But you can see here this gate is 1, this is also 1, so this works. So this is D3, so D3 works. So this is how a multiplexer gets selected for the inputs. Now can you able to understand? Right? I hope you understand this. So if you're not understanding it, again you can re-study again. You can reverse this again. You can see this video and you can get it. Right? Yes. So now let me see 4x1 mux with enable input. Right? Just see the block diagram on the right hand side, top corner. I have introduced a symbol called E. It is called as enable signal. Why we have to introduce this? See, let me give an example for this. In our home, we have fan, switches, everything. We have fan, lights. Okay, it is controlled by switch. Imagine your fan without a switch. It continuously runs, right? So there won't be any control over it. So to control over it, we need a switch. So to make switch, I use enable pins here. Okay. Let us see the logic circuit here. The one main difference here I have drawn is, I have introduced is this. Take this enable pin, enable line, and draw it like this. Okay. It is just a line I have introduced, and that is connected to this gate, this gate, this gate, and this gate. Now as of AND gate, if you look at the AND gate, if any input is 0, your output will be 0. This is the concept I am going to take. So let me introduce a truth table and explain. Okay, in the truth table I have included another column called E. Okay, E. Let me put this as 0. Now if I put this as 0, this input becomes 0, this also becomes 0, this also becomes 0, this also becomes 0. Now what happens? All four gains as input as 0. then no, then here you cannot select any input, right? Because all the inputs are 0. This is one of the simple technique to make it as a switch. Okay, so you can see the truth table again. Just see the truth table. I put this as x here, here also x. X is nothing but don't care. I can either it is 0 or 1. So with respect to the different combination of inputs, I'll get output as 0. Can you understand this? Right? So this enable pin helps you to on the entire circuit or off your entire circuit. Clear? Now the next combination 1. So if I put this as 1, all my gates are enabled with this power supply 1. Okay. Now based on the different combinations, I'll get the output as like the previous one, right? So this is the difference between 4x1 mux with enable input, 4x mux without enable input, right? I hope you understand this, right? Yes. Now next is 8x1 mux. Okay. Let me introduce this logic circuit, right? So this is 8x1 mux. It has 8 inputs D0 to D7 and 3 selection inputs S0, S1, S2 like this. Now base the truth table is, you can see the truth table. Why I have put S0, S1, S2. So far I have given A, B. Now I have given S0, S1, S2. You can give any variable which is comfortable for you. Okay. So now here also the combination works like this. Okay. If I put 0, 0, 0, okay, and D0 will be selected. If I put 0, 0, 0, 1, Y, that is D1 will be selected. Okay. If I put 0, 1, 0, this will be selected. This gate will be selected. Similarly, for the next combination, D3 will be selected. For the next combination, that is 1, 0, 0, this D4 will be selected. For this combination 1, 0, 1, D5 will be selected. For this combination D6 will be selected, and for the last combination, last one will be selected, right? So this is how the mux can be implemented, right? So D7. Okay, this is what we have given with the help of this block diagram, right? So input lines 8, 15, sorry, this is for, similarly we can try it for 16x1 mux. So I am leaving to you, okay, as a user, you try for 16x mux. You can draw a 16 input gate, 16 gates, 16 AND gates, and you can connect to a OR gate and you try it. Okay. So with this I am completing this mux topics. Clear? And there are a lot of problems even in this concept. Let me see that in a different video. Thank you. So thank you. We will see you in another video with a different topic. Thank you so much.